Hello everyone. In this video, we will proceed to the next module, which is canal structures. This is the last module of your syllabus, uh, and only one module is left, that is spillways. In here, we will complete this canal structure module in 3 or 4 videos. So, first, canal structures. Now, regulation works. Introductory part for the module. Any structure which is constructed to regulate the discharge, full supply level, or the velocity in canal, that is known as your regulation work. Okay, what is regulation work? Regulation work means the structure which is constructed to regulate the discharge. That means we have to regulate the discharge to and also the full supply level or the velocity of canal. Okay, now such structure is necessary for the efficient working and safety of the irrigation canal, okay, or irrigation channel. These are the various regulation works and the categories of regulation works. First is your canal fall, next head regulators or head sluice, cross regulators, canal escape, canal outlet. Okay, we will see one by one these five regulation works, categories of regulation works is nothing but your total module, that is canal structures. Okay, now in this video we will study canal fall first. What is canal falls? Canal fall is an irrigation structure constructed across a canal to lower down its water level and destroy the surplus energy liberated from the falling of water, which may otherwise soar the bed and banks of the canal. Okay, canal fall क्या है कि जो भी कैनाल हम लोग इरिगेशन स्ट्रक्चर हम लोग कंस्ट्रक्ट कर रहे हैं उसके अक्रॉस हम लोग क्या करते हैं कि उसकी वाटर की लेवल जो है वो लोअर डाउन करने के लिए, मतलब एक वाटर लेवल है, एक्स सपोज एक वाटर लेवल है, तो उसको लोअर करने के लिए हम लोग उस कैनाल पे ही एक ऐसा स्ट्रक्चर कंस्ट्रक्ट करते हैं दैट विल made the water to fall from the original water level. Okay, that's why it is called as a canal fall. Okay, canal fall क्या होता है कि जो भी वाटर लेवल है, ओरिजिनल वाटर लेवल है कैनाल की, वो कैनाल फॉल के जरिए से हम लोग फॉल कर सकते हैं, नीचे ला सकते हैं. ओके, दैट्स व्हाई इट इज कॉल्ड एज अ कैनाल फॉल. एंड ये जो स्ट्रक्चर है वो हम लोग कैनाल के अक्रॉस ही कंस्ट्रक्ट करेंगे. ओके, एंड अदरवाइज क्या होगा कि कैनाल की बेड्स एंड साइड्स जो है वो इरोड हो सकती है और सोरअप हो सकती है. दैट्स व्हाई कैनाल फॉल्स आर नेसेसरी. नाउ the location of falls. The location of a canal fall is decided from the following considerations. First is, for the canal which does not irrigate the area directly, the fall should be located from the considerations of economy in cost of excavation of the channel with regard to balancing depth and the cost of fall itself. ओके, जो भी कैनाल जो है वो डायरेक्टली इरिगेट, कोई भी एरिया डायरेक्टली इरिगेट नहीं कर रहे हैं, वहां पे कैनाल जो है वो एक्सकावेशन, कॉस्ट ऑफ एक्सकावेशन, जो चैनल की कॉस्ट ऑफ एक्सकावेशन होगी उसके कंसिडरेशन के हिसाब से लोकेट करना है. एंड उसकी बैलेंसिंग डेप्थ एंड जो भी फॉल है उसकी कॉस्ट भी ध्यान में रखते हुए ही हमें क्या करनी है, उसको लोकेट करना है। ओके, सेकेंडली, जो कैनाल डायरेक्टली एरिया इरिगेट करने वाला है, द कैनाल विच इज इरिगेटिंग द एरिया डायरेक्टली, in such canal, a fall may be provided at a location where the full supply level outstrips the ground level, but before the bed of canal comes into filling. Okay, where the full supply level outstrips the ground level, but before the bed of canal comes into filling. ओके, तो जो भी कैनाल डायरेक्टली एरिया इरिगेट करेगा, वहां पे हम लोग कैनाल फॉल कहाँ प्रोवाइड कर सकते हैं, एट द लोकेशन वेयर फुल सप्लाई लेवल आउटस्ट्रिप्स द ग्राउंड लेवल। ओके, full supply level outstrips the ground level and before the bed of canal comes into filling. Now, after the drop, the full supply level of canal may be below the ground level for 1.5 to 1 by 4 kilometers. जो भी ड्रॉप होगा फॉल के आफ्टर, जो भी ड्रॉप होगा आफ्टर दैट ड्रॉप, द फुल सप्लाई लेवल ऑफ कैनाल में बी बिलो द ग्राउंड लेवल। अभी पहले हमें कहाँ पे करना है, वो कैनाल फॉल कहाँ कंस्ट्रक्ट करना है, जहाँ पे आपकी फुल सप्लाई लेवल है वो ग्राउंड लेवल को क्रॉस क्रॉस करेगी, दैट मीन्स वो ओवरफ्लो हो जाएगा। वहाँ पे हम लोग को क्या करना है, फॉल कंस्ट्रक्ट करना है टू लोअर डाउन दी original water level of that canal. Okay, now the third point is the location of a fall may also be decided from the consideration of the possibility of combining it with a regulator or a bridge or any other masonry work. ओके, जहाँ पे भी हमें उसे कंबाइन करना है, पॉसिबिलिटी ये भी पॉसिबिलिटी देखनी है कि वो कि हम लोग उसे कंबाइन कहाँ कर सकते हैं, ब्रिज पे, रेगुलेटर के यहाँ, या फिर एनी अदर मैसनरी वर्क के यहाँ, तो हम लोग वहाँ पे वो लोकेट कर सकते हैं। नाउ द fourth point is a relative economy of providing large number of small falls versus small number of big falls should be worked out. A provision of small number of big falls results in unbalanced earthwork, but there is always some saving in cost of the fall structure. मतलब हमें रिलेटिव इकोनॉमी भी देखनी है, इफ it is feasible to provide small numbers of large falls or a large number of small falls. Okay, but it is unbalanced when we are providing small numbers of big falls. Okay, then earthwork will unbalanced, but here the saving of cost may arise. Okay, मतलब saving cost की हम लोग यहाँ पे कर सकते हैं, but earthwork may be unbalanced because हम लोग small number के large और big fall construct करने वाले हैं. Now the second point here is development of falls. Okay, development of falls. Now जो ancient people थे, they were tries to avoid the fall, and they align the canal in a zigzag route. Okay, in order to increase the length of canal, and लेंथ इंक्रीज एंड zigzag मैनर में कैनाल अलाइन करने की वजह से क्या होता था कि एनर्जी डेसिपेशन ज्यादा होता था। ओके, एनर्जी डेसिपेशन ज्यादा होता था, एंड बिकॉज ऑफ दैट अगेन क्या होता था कि आपकी जो लॉस ऑफ हेड्स है, वो हेड लॉस भी ज्यादा होते थे बिकॉज ऑफ योर फ्रिक्शनल लॉसेस। ओके, तो यहाँ पे हम लोग उसकी अलाइनमेंट लॉन्ग रूट नहीं रखेंगे एंड zigzag भी नहीं रखेंगे, सो दैट वी हैव टू प्रोवाइड दी फॉल. ओके, तो डेवलपमेंट कैसे हुई इसकी? द ईस्टर्न यमुना कैनाल constructed by Mughal emperors has no falls. Okay, and the canal followed in a zigzag path. The falls were first constructed by the British in India in the 19th century. The development of falls since then took place gradually. Among the earlier type of falls, दी डिफरेंट डेवलपमेंट कैसे हुई हम लोग हम लोग यहाँ पे स्टडी कर चुके हैं. डेवलपमेंट इज ड्यू टू द ब्रिटिशर्स इन इंडिया इन 19th century. Before that, there were no any fall in any canal. Canal system is existing, but the fall structure, canal fall structure is not existing in any canals. Okay. Now, what is energy dissipation? We will study this in spillway chapter, but I'll just explain what is exactly energy dissipation. Now, when flood discharge passes over the spillway crest, it has a high potential energy. Okay. Now, that high potential energy will get converted into kinetic energy as it glides over it. Now, this energy, high energy, has to be dissipated. Otherwise, what happen? It will erode the downstream of tow. Okay. Energy dissipation means energy, we have to dissipate that energy, we have to destroy that energy, otherwise it will soar up the downstream of your any structure, hydraulic structure. So this is regarding the development of falls. Now, what are the different types of fall? The earlier types of falls are augie fall, rapid fall, stepped fall, notch fall, vertical drop fall, glacis type falls, and these two, meter and non-meter and contracted and full width fall, are also categorized in types of falls. Okay. Now we'll see one by one. First, augie fall. The augie fall was first constructed on the Ganga Canal. This type of fall we can see here in this diagram. This type of fall has gradual convex and concave curves with an aim to provide a smooth transition and to reduce disturbance and impact. Okay, here this type of fall have a gradual convex and concave curves, and the aim of this fall is to provide a smooth transition of energy and to reduce the disturbance and also reduce the impact. This preserved the energy. Okay, this preserved energy without dissipating it. Due to this, what happened? The augie fall has some defects. Okay, now which are the defects? First is there was considerable drawdown effect on the upstream side, and due to that the bed erosion will occur. Okay, bed erosion will occur is the first effect. Second is, due to the smooth transition, kinetic energy was preserved till sufficient depth was soared out below the fall. And what happened here? The formation of hydraulic jump will occur. Okay, here what happened? Kinetic energy जो है, that kinetic energy will preserved. Okay, so that kinetic energy will preserved till the sufficient depth below the structure was soared up. Okay, so here soaring is also happening and the hydraulic jump is also occur. Okay, these are the two defects of your augie fall, and the structure of augie fall is gradual convex and concave curves type. Okay, now second is your rapid fall. Here the diagram shows the rapid fall. Such falls were provided on western Yamuna Canal. The Augie Fall is constructed on Ganga Canal. Rapid Fall is provided on the western Yamuna Canal. Okay. Now, such falls consist of glacis sloping at 1 vertical to 10 to 20 horizontal. Okay, here slope is provided as 1 vertical to 10 to 20 horizontal. Okay, now the long glacis assured the formation of hydraulic jump. The gentle slope admitted the timber traffic here. Okay, hence the fall worked admirably. Okay, however, there was a very high cost of construction, but this rapid fall worked very effectively, and it has a high cost of construction. Next is stepped fall. What is stepped fall? The diagram shows stepped fall. By seeing all this diagram, I hope you have understood what is exactly the fall structure. Okay, fall is here, you can see it lowers the original water level, again lowers the original water level, and again here lowers the original water level. Okay, like a steps. Here step fall name indicates in the form of steps. It is step fall was the next development of a rapid fall. ओके, रैपिड फॉल की नेक्स्ट डेवलपमेंट है. ओनली द थिंग इज रैपिड फॉल को यहाँ पे स्टेप्स प्रोवाइड नहीं किए हैं. दिस इज द नेक्स्ट डेवलपमेंट ऑफ इट. One such type of rapid fall was provided at the tail of main canal escape of Sarda Canal. Okay, जो सरदा कैनाल है वहाँ पे सरदा कैनाल है वहाँ पे ये स्टेप्ड फॉल एक प्रोवाइड किया है ऑन द टेल ऑफ मेन कैनाल एस्केप. ओके, the cost of this fall was also too high. Okay, as we have explained, the cost of rapid fall is also high. So here this step fall is the next generation of rapid fall. So the cost of this is also very high. I'll again repeat, Augie fall is constructed on Ganga Canal. Rapid fall is constructed on western Yamuna Canal, and this type of stepped fall is constructed on the tail end of main canal escape of the Sada Canal. Okay, now notch fall. Here the diagram shows the plan of one notch, section of notch, and a sill of notch also, sill level. After the development of stepped fall, the efficiency of vertical impact on the floor for energy dissipation came to be recognized. The vertical fall came in the field along with the cistern. Okay. Now, however, with the greater discharges, vertical fall gave trouble. Hence, these were suppressed for the time by the notch fall. The trapezoidal notch fall was first designed in 1864. Okay. Now, here what is mean by cistern? The term cistern is there. Cistern is nothing but that portion of fall which is at the downstream of the crest wall where surplus energy of water leaving the crest is destroyed. Okay. uh, मतलब जहाँ पे भी हम आपका फॉल का फॉल की डाउनस्ट्रीम है वहाँ पे सरप्लस एनर्जी जो वाटर लीव कर रहा है उसकी सरप्लस एनर्जी डिस्ट्रॉय की जाती है. दैट स्ट्रक्चर इज सिस्टर्न. ओके. वो सर्टन डेप्थ होती है जो हम लोग प्रोवाइड करते हैं. नाउ दी कमिंग टुवर्ड्स द नॉच फॉल. दिस फॉल consists of a one or more trapezoidal notches. Here you can see one or more trapezoidal notches were consist in a high crested wall. In a high crested wall, a flat circular lip projects downstream of each notch to disperse the water. Now, the notches were designed to maintain the normal water depth in the upstream channel at any two discharge values. The depth discharge relation was thus maintained with a close approximation in this notch fall. Okay, again, the trapezoidal fall was very successful, and that is adopted in our country for many years. Um, there was a serious defect in this fall that they could not be used as a regulators in addition. Okay, these could not be used as a regulators in addition. Now next is your vertical drop fall. Okay. Now in vertical drop fall, the nappy impinges clear into the water cushion below. The nappy profile जो है that impinges और वो अंदर जाती है clearly into the water cushion. In earlier types of vertical falls, the dimensions of cistern were put in arbitrarily in light of experiences of the designers. Okay. Another device मतलब यहाँ पे कोई क्राइटेरिया नहीं है, उनके एक्सपीरियंस पे ही वो डिजाइन करते हैं. Another device in the form of grid was usually used in the cistern intercepting the dropping jet of water. The uh, consisted grid consisted of bulks of timber, horizontal and inclined, and spaced some centimeters apart. These were later abandoned because the timber grid got clogged and rotted and had to be replaced frequently. Okay, the Sada type falls developed on Sada Canal projects. The type this type developed in Punjab are some of the recent years or recent types of vertical drop falls. In these falls, the high velocity jet enters the deep pool of water in the cistern, and the dissipation of energy is affected by the turbulent diffusion. Next is glacis type fall. The glacis type of fall utilized the standing wave phenomenon for energy dissipation. The glacis fall may be straight glacis type or parabolic glacis type. Commonly, the parabolic glacis type known as Montague type. The straight glacis fall may be with baffle platform and baffle wall. In such case, the formation of jump takes place on the baffle platform. This type was first developed by Inglis, so it is called as Inglis fall. Glacis, straight glacis is also called as Inglis fall. Now, secondly, meter and non-meter fall. Meter fall are those which also measures the discharge of canal, and non-meter are those which does not measures the discharge of canal. For a fall to act as a meter, it must have broad wear type crest so that the discharge coefficient is constant under the variable head. Generally, glacis type fall is suitable as a meter fall. The vertical drop fall is not suitable as a meter due to the formation of partial vacuum under the nappy. The last is contracted and full width fall. A fall may either be constructed for the full channel width or it may constructed for the contracted width. The contracted falls, the latter type, are also known as flumed fall. Okay, contracted falls जो है that are also called as flumed falls. Okay, now the classification of fall. These are the types of falls which we have studied earlier. Uh, Next to it, we are going to discuss different classes of falls. Fall may be divided into four principal classes with reference to the approach condition: class 1, class 2, class 3, and class 4. Okay. Firstly, class 1. Class 1 is the class for falls designed to maintain the depth discharge relation. Okay, first class is falls designed to maintain the depth discharge relation. This is the first class. In this class, the normal depth discharge curve of a channel is maintained and there is neither drawdown nor heading up of water as the channel approaches the fall. Okay, मतलब फॉल के यहाँ जब भी वाटर जाएगा, चैनल जहाँ पे भी जाएगा वहाँ पे ड्रॉ डाउन और हेडिंग अप ऑफ वाटर नहीं होगा. ठीक है. द फॉल अंडर दिस कैटेगरी आर trapezoidal notch fall, low crested rectangular notch fall. Two types. In this in this low crested, the depth discharge relationship is not so maintained as the trapezoidal. Okay, the second type of fall is liable to cause silting of the channel and it is run at the lower level than the design level for the long periods. Second class is falls designed to maintain a fixed supply level in the channel above the work. This is the second class. In such type of falls they maintain the nearly fixed water surface level upstream of the work and necessary under some circumstances. Okay, first is when the hydraulic power station is combined with the fall, अ, तभी वो क्या करते हैं कि वाटर लेवल फिक्स्ड करते हैं. And second is when the subsidiary canal takes off some distance above the work. Okay, तभी वो वाटर लेवल फिक्स करके फ्लो होते हैं व्हेन हाइड्रोलिक पावर स्टेशन कंबाइन करना होता है, एंड सेकेंडली एक सब्सिडरी कैनाल अगर वहां से डाइवर्ट करना हुआ तो। The principal types of fall under this class 2, are siphon fall or siphon spillways, high crested weir fall. Two types. The falls under this category suffer from the defect of silting caused in the channel above the work. The crested fall are generally constructed without fluming, and hence discharge intensity per unit length of crest is low. Here energy dissipation is simpler. It can also be used as a meter fall. Okay, that means it can also measures the discharge through that canal. Third class is class 3, which is falls designed to admit the variations of the surface level above the work at the will of the operator. Okay, third class is falls designed to admit the variations of the surface level above the work at the will of the operator. Okay, these falls are designed to admit the variations of water level on the upstream of the work according to the requirements. They also serve as regulators. The regulation is done with the help of sluice gates, horizontal stop logs, and vertical needles. In practice, falls of this class are confined exclusively to rectangular notches, as the trapezoidal notch cannot be used for this purpose. ओके यहाँ पे रेक्टेंगुलर नॉचेस जो है वो यूज करते हैं, ट्रेपेजोइडल नॉच बिकॉज हम लोग यूज नहीं कर सकते यहाँ पे. ओके, नाउ दिस इज क्लास 3. लास्ट इज योर क्लास 4. Okay, class 4 is miscellaneous types. Falls under this class are designed from special considerations without any reference to the conditions of approach. The falls under the miscellaneous types are designed from special considerations without any reference to the conditions of approach. Okay, the principal types under this class are three types. I'll explain it. Before that, for class 1, the principal types or categories are trapezoidal notch fall, that is for class 1. Falls are trapezoidal notch fall, low crested rectangular notch fall. Okay, two types are there. Notch falls, दोनों ही notch fall है. First is trapezoidal notch fall and second is low crested rectangular notch fall. ओके, क्लास 2 के अंडर जो आएंगे वो हाई क्रिस्टेड वियर फॉल एंड साइफॉन फॉल. ओके, साइफॉन फॉल एंड हाई क्रिस्टेड वियर फॉल, ये दो टाइप्स जो है वो क्लास 2 के हैं. क्लास 3 के लिए rectangular notches, we can use the rectangular notches exclusively. So because trapezoidal notch यहाँ पे हम लोग यूज नहीं कर सकते, एंड दे कैन बी serves as a regulator. Now the fourth class is miscellaneous. in this, under this type or under this class, there are again three uh, principal types. First is your cylinder fall or well fall. This diagram shows the cylinder type of fall. In this cylinder type of fall or a well fall, water is thrown into a well over a crest from where it escapes near its bottom. यहाँ पे वाटर थ्रो किया जाता है एक वेल पे, from the over the crest from where it escapes near the bottom, जो bottom पे escape की जा सकती है, ठीक है, that so that it is called as a well fall or cylinder fall. The energy is dissipated in the well in turbulence. They are quite suitable and economical for low discharges and high drops, and are used at tail escapes of small channel. Okay, these type of cylindrical type of falls are suitable and also economical for the low discharges and high drops. जहाँ पे हाई ड्रॉप है एंड डिस्चार्ज लो है, वहाँ पे हम लोग ये वेल फॉल और सिलेंड्रिक फॉल यूज कर सकते हैं. ओके, एंड हियर दी also they are used at tail escape of small channel. Okay, as because these are the in the form of wells, so high drop भी अगर हुआ बट लो डिस्चार्ज, तो वहाँ पे हम लोग एनर्जी डेसिपेट कर सकते हैं एट द वेल itself. Okay, so it is suitable for high drop and low discharges. Hmm. Now second type or second class, second type, principal type under this class 4 is shoot or rapids. Shoot or rapids. They conduct, these type of falls conduct the stream on open inclined trough. These conduct the stream on open inclined trough. Okay, last is your pipe fall. In this type, pipe replaces shoot. मतलब जो शूट फॉल्स है ये एक्सट्रीम कंडक्ट करते हैं ऑन ओपन इंक्लाइन ट्रफ. ये जो है वो ओपन इंक्लाइन ट्रफ है, एंड पाइप फॉल जो होगा वो क्या करेगा, शूट की तरह ही वर्क करेगा. ओनली द डिफरेंस इज दैट दे रिप्लेसेस दैट शूट. मतलब वो जो है वो ओपन इंक्लाइन ट्रफ है, मतलब ओपन इंक्लाइन ट्रफ पे वो कंडक्ट करेंगे एक स्ट्रीम को. तो यहाँ पे जो ओपन है वहां पे वो पाइप को रिप्लेस किया, तो क्या हो गया, वो पाइप फॉल हो गया. ठीक है, सो दैट इट सेज दैट द pipe fall replaces the shoot fall or a rapids. Okay, this is about the canal fall and the necessity of canal fall, and also types and classification of your canal falls. That in the types, I'll again repeat or revise. In the types, canal falls are uh, classified into augie fall, rapid fall, stepped fall, notch fall, vertical drop fall, glacis type fall, meter and non-meter fall, contracted and full width fall. Okay, and again the classification, in classification of falls are classified into four classes: class 1, class 2, class 3, and class 4. Okay, class 1 is falls designed to maintain the depth discharge relation. Class 2 is falls designed to maintain a fixed supply level in the channel above the work. Third is falls designed to admit the variations of the surface level above the work at the will of the operator. And fourth is miscellaneous types. Okay, this is about fall. I hope you have understood what is fall. Fall is a simple phenomenon. You can see here that it simply lowers the original water level or full supply level of the canal. To it is used to lower down the water level of canal and destroy the surplus energy liberated from the falling of water, which may soar the bed of your canal. Okay, up to this we have finished canal fall. In next video we will move for the head regulators or canal regulators, cross regulators. Thank you.